Good afternoon, everybody. I want to thank you for joining us for our first of three lubrication seminars, webinars. Before we get started, I want to remind everybody to make sure you got your cameras on. You should be able to see myself, Carl, and you should have a video or a shot of a dryer sitting over there in our shop. Before we get started, I want to kind of introduce the team and who you're going to be talking to and visiting with for the next hour or so. You got Bailey, who you can't see, but she's going to be helping us field your questions. Jason, who's there at the shop, he's going to be walking us around the dryer there. Carl Elling with Whitmore, and myself, Buck McVaney with Industrial Kiln and Dryer, Southern Plains District Manager. With that, Carl, we'll let you start driving.
Copy that. Well, thank you everyone for showing up. We're just going to go over the highlights of as far as our basic lubrication of the rotary kennel and some of the applications that are involved with it. We started this partnership between IKD and Whitmore towards the end of last year, and we're ramping up for this year. And so we're bringing best of all worlds as close to you guys as possible as far as just a package partnership, if you will. So with that being said, let's dive into this thing. So if you guys do have questions, Bailey is going to be watching the chat and she'll be able to stop us and ask those questions if you have a general question to ask as we go through the presentation, so we can stop and go from there. So we'll try and keep track as far as time, so we don't waste your guys' time. All right. Let's dive into this little thing. So today's session is just basic lubrication. Next week is girth gear lubrication. And then session 3, May 28th, is going to be on the tire ID, bearings, support rollers. So we're going to dive in a little bit deeper, but we're going to focus today on the basics of lubrication.
Just a reminder for everybody, these are all at the same time for the next 3 weeks. Today is just kind of a general overview. We're not going to get too deep into any one particular component. But again, we invite you to ask questions as we move through this. We like try to address them as we go.
Yep. Good deal. Thanks, Bud. I won't read through these things, but this is about our partnership. You know, Industrial Kiln and Dryer have been around there providing trustworthy, optimal solutions concerning lubrication. They also do the repair work on rotary equipment, so they're a great partner to have. Whitmore, we've been in the lubricant manufacturing business for quite some time. We were involved with the space shuttle, the expansion of the Panama Canal, so we've been around since 1893, based in Rockwall, Texas, just northeast of Dallas. But to give you an idea, we also manufacture oil safe, which is all the color-coded type stuff, as well as we manufacture air sensory, which is desiccant breathers. So just to give you a little platform as far as what we do, but we specialize in open gear and grease manufacturing. All right. So talking about basic lubrications, two primary ingredients that make up a lubricant, as we all know. You've got your base oil, and you've got your additives, just to keep it simple. When you add the greases, that's when you get into soap thickeners. But other than that, lubricant has base oil. There's 5 base oil groups that are out there in the market space between API 1, 2, 3, 4, and then 5. So depending on how you want to make your lubricant, what the applications are, it kind of drives what kind of base oil that you use. But where the magic is in the additive packages. This is the chemistry behind the lubricant that allows it to go above and beyond just a base oil, depending on what the operating environment is. But its primary purpose is to help keep any impurities and contamination at bay. When you're looking at the primary properties of a lubricant, the number one thing that you look for is viscosity. So depending on the speed, the load, and the temperature, that's the number one core thing that you want to look at is viscosity. The other things as far as properties of lubricant, you got to look at for oxidation, demulsibility, flash point, depending on how hot the environment is, what the application is, and also pour point. If you're up in the really cold, and you're dealing with a really thick fluid, it'll take you forever to pour that thing out. So sometimes you got to heat it up or keep it up at room temperature so it actually will flow. But these are just some of the core things. These are real basic. So we're going to kind of dive in and bring this in to the lubrication of the rotary dryers and kennels.
Before we get too far, Carl, let me ask you,
Yeah.
when we talk about additives, what are some of the additives that we put in or that would be put into these lubricants, and why? I mean, for example, for rust or corrosion, what are some of the things that would be included in as an additive?
Yeah, rust and corrosion inhibitors would be added in case you want the lubricant to stay on the surface and provide a layer where you've got a layer between the air and the metal, because metal will oxidize and will start rusting. So sometimes you'll put additive in there to prevent that one. You've got extreme pressure additives. So if you got 4-ball weld, if you got two surfaces as far as metal surfaces impacting one another, sometimes you can get away with the viscosity of the oil because of the way the equipment is operating. Other times you've got shock, load, that you need some additives as far as solid like moly, graphite, those type of things that you would add into it to help with the shock resistance and impact. Viscosity improvers. That's one thing that you can actually add into the oil to where as the temperature gets hot, the viscosity in VI will help keep the viscosity thick as it heats up, and it wouldn't thin out as fast. So you got some polymers that will actually expand as it heats up, so it'll keep the viscosity of the oil thicker than it would be by itself.
In instances where we're not applying this lubricant, I use an open gear lubricant as an example, where we're not applying it to a new surface. Are there any additives that we use or that is used that would help with existing wear or asperities in the two components, the gear and the pinion?
It depends. This is where you get in the uniqueness as far as the chemistries. Different manufacturers have different approaches. Some will use solid EP type of additives like moly and graphite that will help protect that. They'll use viscosity. So if some of them are running like in a sump application where you got an idler gear that's kind of splashing it in the gear oil, and it'll splash into the pinion that splashes onto the girth gear or bull gear. They basically go by viscosity, a real thick fluid. A lot of times you'll run into an ISO 1000 or 1500 thickness of fluid in those sample operations. Others that are getting sprayed on, dripped on, you can drip with grease, you can spray with grease. Some of the asphaltic, the older technology were some of the best performing, gear oils out there. Unfortunately, we found out that they're a little harmful and carcinogenic type stuff in there. So, there's some manufacturers that still have it because that's what people really want. We do the same. We still manufacture it by customer demand. But with some of our chemistry we've come out with, we're utilizing a polymer that allows us to, it'll look and act like an asphaltic, but it's environmentally friendly. You can dispose of it as used oil, but what's nice is when you run this particular one, just speaking for ours, we'll actually start seeing some surface improvements as far as if there's a damaged gear or something like that, you'll start seeing some of the repair on it.
We're gonna dive into the gears. We start going through the unit and the different components as we go. I'm sure we'll address a little bit more of that as we go.
Yeah. So, we manufacture quite a different lubricants because of the applications that are out there. Not every one unit, even within a plant, operates the same. So,
well, we got a picture of we're going to talk about some of the components. I believe it's on the next slide, Carl, of the different areas that we want to address and focus our lubrication on. We'll just start from the right side, and hopefully you guys are all able to see this. But when we talk about the tire area, Some folks call it the riding ring, the face, the contact area between the trunnion or support roller, underneath the tire bore or the tire ID. We want to talk about the gearbox essential, right? The drive bearings or pinion bearings, the gear and pinion itself, whether it's helical, spur, depending on whether dual driven, there's all types of and different ways to drive these units, even chain.
Yeah.
Support rollers, we just mentioned the support roller contact between the tire and roller, and then our thrust rollers there at the end. Commonly overlooked. It's small. It's underneath the dryer. You don't see it, so it kind of gets overlooked. But equally as important, because of that metal to metal contact, that we keep that lubricated as well.
Good deal. There we go.
All right, so the first one we're going to talk about is our trunnion bearings or support roller bearings. I think we're going to get Jason to kind of drive over and get us a shot on the unit over there of the support rollers. While he's getting his stuff together there, Carl, why don't you tell us a little bit about the bearing lubricant?
Yeah, in this particular one, depending if it's a kennel or a dryer and the weight, but a lot of times, like the dryers, you'll end up finding a grease pack type of application for this. So when you're looking at your different type of greases, a lot of people will use your common lithium grease that's commonly available. But when you start taking a look at the weight that's involved, the temperature, and if you've got different types of greases within your plant, you got to think about compatibility. So you don't want mixing greases in the bearings. And then also depending on the operating environment, temperature, ambient, sometimes a mineral grease for the base oil in the grease is sufficient. And then synthetic for the colder Arctic type of applications, that'll help you out there. But typically what you'll run into when you're looking at the grease is try and focus on the 4-ball weld or the load. Look at your temperature as far as your range from a cold temperature to hot temperature. Sometimes you'll look at dropping point for your higher temperature. This is where the soap and the base oil kind of start separating. And then your type of soap thickener. A lot of people use lithium complex. There's calcium sulfonate. There's aluminum complex. Just kind of be aware of what's out there. And then other type of trunnion bearing applications are actually used. You've got oil that is used. Typically, it's an ISO 680 for the water cooled, and a lot of times with ours, you can get away with working with mineral still. Some people have elected to go to PAO just for shear stability, also deemulsibility. So if you got a water leak in the water cooled unit, that synthetic will help separate the water from the oil. So you can actually drain that off as you're operating in case you are trying to get out to a planned outage. And then a lot of people are starting to move into where they don't use water cooled. So they're using a PAG or a polyalkylene glycol type of gear oil in those applications. And that's where viscosity is key. But start looking at your load application GP values. I know that we test ours, which is about 315 kilograms. And some of our competition out there don't even list it because it's not a very high value. They're kind of basing everything off of their viscosity index. So there's a balanced approach to some of these applications. And sometimes you're going to find out is not one oil is going to fit everything. So application is how I've always been trained. Look at it and then start thinking about all the different parameters and influences that you're taking a look at. So let's go to little Jason's beautiful picture here. Buck, if you want to kind of walk him through on this one.
I'm sorry, I was having a hard time hearing that last bit, Carl.
Okay. We're on the full synthetic or just zooming in where Jason is?
Yeah, where Jason's at.
Okay. I don't know if you want to take them through this one with your.
So this one here, we just have a regular standard Dodge bearing housing with our bearings in here, kind of like you were talking about, Carl. You know, this is more on the dryer side of things, our smaller units that we see, you know, and this will use the actual grease instead of the oil lubricant.
Right.
Gotcha. Good deal. Thanks, Jason. Sorry, my screen's kind of going in and out on this one. Yeah, cool. Let's move on. Alright. So when we're looking at the face of the kiln tire and the support roller, a lot of your operational conditions, you know, the load is extreme because you're carrying everything that's not only in the actual rotary equipment, but the rotary equipment itself. So these can be a wide variety, also depends on the length. So the longer the kiln, the older technology. So the newer technology, you got shorter ones. You know, so just to kind of give you an idea as far as what you'll see out there as far as 2 to 3 pier. Sometimes you'll run into 4. So, but in this particular application, you know, your boundary lubrication regime is what you're kind of looking at. And we typically use a dry film lubricant in this one. A lot of people use a graphite bar. Some people are spraying graphite on there. Some of them are using graphite type of dust where they sprinkle it onto the support roller for the pinch point. So just something to consider. There are 2 types. There's free floating type of support roller, and there's also the driving unit. So you got friction driven. So, and we've got lubricants now that compete with the graphite bars. It's moly blocks. So this is basically moly mixed in with a polymer, a thermoplastic type of stuff, and it'll provide a consistent dull finish across the entire face. It'll replenish itself. What's really nice is it doesn't glaze over. And then if you've got your particular rotary unit that's exposed into the elements, it will not wash off. So there's a lot of good things about this. And we just developed this and we're just commercializing it. So we've been working with Industrial Kiln Dryer and a couple other distributors out there, just testing this and getting it out in the market and getting some feedback. And so far it's been really, really great technology out there. So just to give you an idea, if you guys run into problems where it's constantly glazing over, this might be something that you want to contact Industrial Kiln Dryer Group and have them give you a quote on this stuff.
Well, I mean, and let me add to that. I mean, it's part of a normal maintenance practice with the old graphite blocks. It's something that you have to do with regularity. Now, how often that is depends on, you know, the operation of the unit. 24/7, 365 is most people's goal and plan. So those have to be pulled out, scuffed up, the old graphite block, whereas these don't. So from a maintenance standpoint and your maintenance personnel standpoint, when you can put those in and basically forget about them and they will continue to lubricate and do their job, this is a tremendous help when we're talking about our preventive maintenance programs and ways that we can get efficient at it and still be able to get the job done. So far, the feedback that we've had on these has been extremely positive. They're working well in the field, and we've got them in several plants under different environments, outside, inside, outside covered, and still positive feedback so far from all of them.
Yeah, this product was actually developed from a rail industry. So where there's positive friction, so if you do have a basically a friction driven system, this actual block that we develop provides positive friction. So that way if it starts to creep or slip, it'll catch up to 0.42 coefficient of friction. So it's been great. If it can handle a rail, 250 ton, railroad engine going down on a curve and hold it on its track, it's providing enough friction on there to where it'll grab. So it's really cool technology that we're taking to market.
Now, guys, the one thing with a graphite block, when we're out in the field, you know, we see graphite blocks chipping off, breaking apart. You know, a guy pulls it out to clean it. He drops it down on the ground. It breaks in half and it's done. What about the blocks we have here?
It'll take a little bit of abuse. It's a thermoplastic, so it can absorb some of the shock if you do drop it. Jason, if you want to, a lot of people like it's so dense. It's going to be a little bit more heavier than the graphite blocks that you see out there, but the moly blocks are pretty dense. And then if you want to wipe your hands on it, it'll show you how much, it's just a real, basically a half a micron thickness as far as film strength that it's building on just the one surface. So when you put it between that, it'll transfer easily and quickly from the support roller to the bull gear. You've only got about a micron thickness. So it's not a real thick product, but when you see it on the actual surface, it's a nice dull gray finish, and it's consistent across the entire face of the unit. So it's pretty to look at versus the other. And you can also use this on your thrust roller if you're currently using graphite blocks on a thrust roller as well.
And encouraged. I would encourage, drops or whatnot. We can definitely get these sized for your thrust rollers to, again, we go back to metal to metal contact to reduce friction, reduce load, and run efficient. This is an outstanding product.
Good deal.
Anybody, before we get any further, does anybody have any questions about anything that we've covered so far?
Yeah, I think there's also a handout if you guys want to download the PDF version. I think Bailey's got that available for you guys and gals, just in case.
No questions so far, guys.
All right, excellent.
Let's jump over to motor bearing. So this is the unit that drives the whole, that's where it all starts, I guess, from the power standpoint. Majority of the time, I will use a polyurea type of grease because it's an electric motor. That's what they're designed to. So if you ever seen your electric motors out for service, your service guy will probably put polyurea back in it. So just kind of keep that for knowledge. We do have another grease that can handle this particular one, but that's if you want to use one grease in several different other applications and do a grease consolidation effort. We usually take that on a case-by-case basis, but we do have that technology available. So just to kind of give you guys an idea of what to expect, but loading your frequency, and typically polyurea is probably one of the most common for this application of electric motors. Couplings.
I think we'll move into couplings next, don't we, Carl?
Yep.
Nice.
So couplings, our product's Vortex, but it's a coupling grease. This is one that's ours is a lithium polymer mix with and it's very tacky. So this thing's constantly spinning with centrifugal force. So it'll adhere to the metal surfaces. Consumption is lower, but some things that you want to focus on is literally, look for the weld point because you're trying to protect the two surfaces. Your soap, what type of thickener are you using? Make sure you're putting, the consistent type of coupling grease in there. And then what type of base oil are you working with? Is it going to be mineral synthetic? Also start, consider looking at the scar wear results. This value, the lower is better when you're doing comparisons. The base oil viscosity, this will be key for this particular application.
Moving over to the gearbox, Jason.
Yeah, let me go. There we go. Cool. Good job. Sorry, I've been looking at the presentation the whole time, so I'll try and look at the screenshot too. So here you've got your gearbox application or gearbox reducers, basically whatever the electric motor is driving, depending on the speed and torque that you need, is where the gearbox comes into play. That'll drive the pinion, that'll turn the bowl gear. So a lot of the times you'll run into where these things are cooled with either, actually for the gearbox, you'll run into extreme applications where you got impact from one gear meeting another gear. So look at your 4-ball weld, look at your temperature as far as operating temperature when you're doing a comparison. Take a reading of it and get an idea as far as operating temperature, and then compare that to the product data sheets or technical data sheets that are out there for the product that you're using. Put your application challenge, you've got boundary, mixed regimes, you're trying to do hydrodynamics where you've got fluid in there. But look at your 4-ball weld temperature. Are you operating cold, hot, dusty? Does it have a vent? If it's got an open vent, consider using a desiccant breather in those applications. If you can shield it away from the radiant temperature from the kiln or the dryer. A lot of people will put a heat shield over there, and then you've got the ability to use a desiccant breather. So desiccant breathers typically help you reduce the amount of moisture in the air that's getting sucked into the gearbox. It's also helping reduce the amount of particulates from the airborne type of particulates. So very good use of desiccant breather in these applications. When in the field, we typically run into where they're just open vent. So it's attracting anything and everything outside that operating parameter, which will reduce the length of or your effectiveness of the gear wall. So, and there's some reliability.
This particular gearbox oil, pardon me, Carl. This particular gearbox oil is not designed specifically for rotary equipment. Your dryers or kilns. This gearbox oil can be used in a variety of gearbox applications.
Absolutely.
Conveyors, screw conveyor, any type of gearbox. And when we talk about on the rotary equipment with the heat that builds moisture, let's talk a little bit about the lubricant as it applies or as it pertains to moisture entering the gearbox.
Yeah, when you got moisture entering it, what happens is you've got oxygen, so your oxidation protection within the lubricant, you're depleting that additive pack. So you're weakening that gearbox oil. So by doing that, you can either gel it up. If you get too much, you got something else that's contaminating it, or you can thin it out because it's getting a higher temperature and it's just not able to keep itself together. So. Good deal. All right. Any other questions?
No questions on a gearbox?
Right. Yeah. A lot of these things with the gearbox, look at your AGMA, look at your OEM specs. That'll usually help drive the viscosity of the oil that you need to be using. So if that might be one of the comments that I would go ahead and make. Use that AGMA 8, 7, or 5. Typically an ISO 220, 320, 460.
This might be a good. I don't know. Most guys are, and if you're not, it would be a good time to start. If you're doing oil analysis, having an oil analysis done, which we can do for you, we can help you with that. But if you're not, we definitely would encourage you to do an oil analysis with regularity.
Yeah, regularity meaning quarterly or semi-annually on these, depending on your environment.
Yes.
Good deal. And Jason, taking a good picture of the gear, open gear application as well. So here's their system. Here's when you come to their shop and their training class, this is what you get to operate and play around with. So you can actually see how the lubricant is applied, through the spray, the spray and the pinion on this particular one. And so you can see, by adding air pressure, lowering air pressure, you can do all sorts of different adjustments to get the type of coating that you want on it. And then there's a system right there. So if you want to make the quick adjustments, you can see how this affects the application of the lubricant itself. So it's a great training module that they have there at their university.
That's a great point, Carl. So at the IKDUs, some of you may have seen, a lot of you may have seen the literature and possibly even been to them, and would encourage you to come or come back for 101s and 201s. But all kinds of adjustments are made. We go through all the components and functionality of the unit. This is an actual rotating drum. It's powered, so it's a great week of learning and training up there. So when we talk about the open gear loop on this particular application, like Carl mentioned, this is going through a spray lance or a spray bar system, automated spray system, frequency, how often it's sprayed, and then the duration of the spray. So the amount of lubricant that's actually being applied to the gear is all goes through a ratio and a conversion formula. Best application method, probably. Definitely would encourage folks to use a spray method if they can, versus a sump or an oil bath, where the contaminants kind of stay and they're stuck and get recycled back through the pinch point between a gear and a pinion, adding or furthering the damage, or causing new damage. One of the and we had mentioned this earlier, is the additive that reduces friction but promotes the smoothing of surfaces. So we've got asperities in a gear and pinion, but with the additives in this open gear, that'll promote those, almost a lapping effect. Is that fair to say, Carl?
Yeah, it's hard to describe it, but yeah, I mean, after about 300 hours of running this, whatever damage that you had before in the gear, you can see where it's kind of softening out the damage as far as the pitting, the scuffing. It's pretty cool technology. But yeah, and typically when we apply this, we'll apply it to the girth gear or the bull gear. We wouldn't apply it to the pinion because the pinion's moving faster. And so with this one, even though it's a tacky type of asphaltic looking material, once you spray it on the bull gear, that allows it enough time to kind of thicken up as it makes that full revolution. It's not dramatic as far as thickening up, but it does thicken up. And it's a semi-translucent, so I love the idea of coming up with the name of Open Gear Sorted Clear from IKD perspective, but it is a translucent type of product. So number one, you can see it spray onto the gear, so you know you're getting a good coating. So you know the spray nozzles are not getting clogged up. It's a good, easy test that you can easily identify. If you're using a strobe light, it won't bounce back at you as fast. If you're using infrared, it won't flash back at you as far as you'll get a pretty good reading for pictures and documentation on a weekly basis if you guys do that type of practice. But what's nice is you'll spray it on there, and we usually typically take an average of all the AGMAs, the Metsos, the FL Schmidt, and we do all the calculations and come back and go, okay, here's our target. And then, we'll find out where the end user is today, what you guys are doing. How do you make adjustments to the system? Sometimes we'll walk into the plant and nobody knows how to make an adjustment on the system. So we kind of walk through everybody as far as how to make the adjustments, where we are today, where we'd like to get to, and we kind of optimize that way by using this product.
Just one thing that I wanted to key in on is the sort of clear, as we're, and we have to look at things from a maintenance standpoint, or I try to. So when we're doing gear inspections and we're using that thick, heavy asphaltic, there's usually costs involved with getting that off to do a proper inspection so that we can go through the teeth on both the gear and the pinion to look for wear, cracks, and that can be a very time-consuming, costly project. With it being semi-clear or sort of clear, I guess, translucent, this doesn't require all that cleaning time and cost. So it's it's very helpful from a maintenance standpoint. Talk us, Carl, about is so if we're using for our current application is the asphaltic. We're using that dense, thick, heavy asphaltic, but we wanted to transition into the. Do we need to clean it off? I know the answer. I'm just kind of playing devil's advocate here, but so can we just simply transition into the clear gear, or excuse me, the open gear?
Yeah, on this particular one, if you are using asphaltic, we typically would purge the lube line so you could start, applying it, but you wouldn't have to use any special cleaners or anything like this. What's nice about this particular product, it doesn't harden like the asphaltic does. So if you're cleaning the open gear guard, once or twice a year, this particular maintenance item, you can scratch it off your list. So when you spray this thing on there, it is tacky, it'll cling to it. But once it, gets used up, you can dispose of it, because it'll run into whatever contraption you have to guide the oil down into. So it could be a pail that you're leading it for the drainage, or down to a keg, drum, or even a plastic tote, if you will. So it'll remain flowing, and so when it comes to maintenance, you can wipe it off the teeth and take a magnifying type glass as far as a picture and just recoat it and go back in operation. It depends if you're down or not, but as it's running, looks beautiful. You can see through it. You don't have to wipe it off if you don't want to, but a lot of people will say, all right, let's take a look as far as some of those things. I've got some really damaged gears that I've used this product on it was kind of like a chassis grease being used for an open gear application. So it was really pretty bad after about 6 months of running. So we put the Lube on there and just ran it. And in about 300 hours, you could take your thumb initially and you can run it across the tooth of the pinion and almost cut yourself. After 300 hours, you can run your thumb over it and you could feel it had really softened dramatically. And that wasn't, it wasn't the same tooth, but damage was so bad that we're slowly adding more to it. In fact, the customer wanted to go an extra 6 months of running it because they saw the improvement. Right.
And this is last point I'll make on this, other than the importance of the lubrication. And if some of you guys have the spray lance or spray bar automated spray system, I'd urge you to confirm your frequency and duration to make sure that it is correct, that you're applying the right amount. You could be over application or over applying, under applying, and we found that in several cases too, where we just weren't getting enough of the current lubricant. But when this goes down and it's time to get rid of, is it hazardous waste?
No, it's not considered hazardous. It's considered used oil, so there's not any thing special in this thing that would be hazardous waste or anything like that. So it can be disposed of as used oil.
Spent all. Okay, very good.
All right.
Any questions so far, fellas, ladies, in case? Excellent.
Quiet group, man. We're answering all questions. All right, let's move on. So here's your thrust roller bearings. So typically we'll use a grease in this one. So core thing to be looking at is the 4-ball weld point. Look at your operating temperature, of course, always keep that in consideration. If you guys are washing down the units, look at your water washout. And then also look at your soap thickener. So if you guys do decide to use, if you're using different greases around the plant, not all greases play nice. So we all know that polyurea doesn't play nice with other greases. So just kind of keep that in consideration. But I typically find lithium based type. Some people will pay extra to have synthetics in here. Sometimes that's not, you don't need synthetics in this application. So just kind of be aware of the temperature around this one. And then if you're using anything to coat the actual thrust roller itself, as far as a graphite block, this is where WSSL product or solid stick lubricant would be applicable as well. It could go in that same spring-loaded cartridge.
Definitely, and on especially on kilns, high heat dryers where, you know, you're seeing a lot of temperature or a lot of heat on the bottom side of that unit, you know, just like where the bearings are. Be cautious of the grease and the lubricant that you're using there. Definitely want to use a lubricant on the contact surfaces between the thrust roller and the tire.
Yeah. You know, the single point lubricator, you know, both this and also for the, you know, the thrust bearing that you see right there is for the Dodge bearing house. Some people will use automatic lubricators. So, you know, look at the capacity in there and frequency and then kind of dial it in there. A lot of times we find that these particular applications are extremely over greased. And too much grease, you're containing all the heat in that box where it's not allowed to cool off. So just be very aware of how much grease that you're putting in and the frequency.
Excellent.
Another thing with that, Carl, so if I'm over greasing my bearings there and it's pushing out the seal, is there a possibility of that possibly bringing contaminants back into that housing?
Yeah, it depends on how the bearing is breathing. I mean, if it's clogged up and, you know, there's usually a little vent somewhere, it's just pressurized. So as you wipe it back off, a lot of times, you know, people wipe the contaminants right back into where the seal is. So the theory is when you're putting grease in, you're trying to push the contaminants out. But if you got a bad seal, that seal may not be doing its job properly and you're actually introducing contaminants. So then just make sure, a lot of times, you know, if you don't have an automatic lubricator on there anyway, make sure you're using a grease cap or something like that just to keep some of the elements from, you know, being introduced into the bearing as you apply new grease in there. So something to consider. Good point, Jason.
One other thing I'd point out on it's not so much on kilns because they're going to see high heat, and most of them typically have some type of heat shield between the kiln and the bearing housing itself to help at least remove some of that radiant heat coming off of the kiln. But if you're experiencing excessive bearing temperatures on a low temperature unit, then there may be a mechanical issue going on. The way that the bearing and the trunnions are skewed, the thrust that's put on them. So if you're realizing continued high temperatures in a bearing, it may be a mechanical issue as well. Just something to consider.
Absolutely. Good point. Cool. All right. Sorry, I advanced the slide and didn't realize I did that. But move on to slipper pads. This is a love-hate relationship with me because I like using a water-based graphite solution, and it's fun to actually do demos, although it could get a little messy depending on how well you're good at it. So with practice, I'm getting better at it. But the lubricant, as far as I guess the tire ID would be the best way to communicate this, as far as that's why you're lubricating this one. A lot of people use the chocolate bars. It's basically graphite mixed with a little wax and they melt. Sometimes you don't know if it melts all the way across the inside of that ID. So with the graphite solution that we have, it's basically a synthetic graphite milled down to 1 to 2 microns, and it's in a gel, and we can dilute that with water. And typically the sweet spot has been 10% solution, so 9 parts water to 1 part of the actual WBL 52 product. And what's nice is you can use a garden sprayer, stand about 2 to 3 feet away, depending on the pressure that's in your garden sprayer, and you can spray this thing, and it will wick not only on the side of the tire if you want to lubricate that one, just because it make it look nice, but once you hit the slipper pads, it'll actually wick inside and there's very little steam that's generated, but you'll see a little bit of steam. But it'll wick inside and you get a nice even coating on the inside. So we usually do this. It's either 1 or 2 passes as far as revolution on each side, and that's going to be once a week, which is where we get the 52 in the product name, because there's 52 weeks in a year. So once a week application. What's nice is this stuff doesn't give off any odor. So some of the cement plants I've been in that have complained about on the hot end, the chocolate bars will give off a certain odor and they'll melt off pretty quick. So they don't like the odor, and so they're starting to use this particular product in replace, and they're liking it. It's also a good safety thing, because now you're not really close up into the unit. You're not getting your hands close to where you've got to insert the chocolate bar. So just to give you guys an idea.
Yeah, and one of the other things too, so Carl mentioned that the chocolate bar, easy bar, depending on, you know, what you're accustomed to calling it. You guys are using those on kilns. Dryers typically don't see the temperatures that the kilns do, so that you're not going to get that, you're not going to reach the melt point. Nevertheless, you still have to deal with the creep. The creep's a natural function. So by lubricating the idea of the tire, you're not increasing creep. However, you are reducing friction because of the creep between the bore of the tire and the tire support pads. That metal to metal contact, again, reiterate, any metal to metal contact, you want to try to reduce the friction as best you can. So with a low temperature dryer application, this is a great thing to use, as well as with the kiln higher temperature applications. The easy bars, you guys that are using them know what I'm saying. They're nasty. They're a horrible mess. This is a much cleaner way to do it. Especially when you start experiencing shell conditions, where if you are realizing a lot of creep, you know you need to repad or reshim your unit. You could be experiencing shell cracks in and around that tire area that you wouldn't see. It would be masked by that easy bar or chocolate bar, whatever you're used to calling it. This is not going to mask nearly as bad as that thick, heavy lubricant that you were applying. This is a great product. But again, it's one of the things, and since we're talking about basic lubrication, it's kind of like a thrust roller lubricant. Not lubricating the idea of the tire or the tire bore, commonly overlooked, but extremely important and needs to be done.
Yeah, if you guys are interested, I've been working with industrial kiln dryer and sending them out little quart samples, so we can actually do a demo and leave the unit with you guys. So if you guys want to get a chance to work with it and play with it, we've used this stuff on hot change for dry film application. So it's got versatility. Just think of it as liquid graphite, and if you're looking for, if you've got a dry film application that you want to try it on, this might be something you guys can reach out to them, and we can do the demos. And,
yeah, that versatility is a great point. When we talk about, we haven't, but when we talk about the sealing areas, if you got leaf seals or whatever the sealing area is around your unit, you know, that's a great place to lubricate as well too. This product would be perfect in a leaf seal environment to help reduce that wear on those leaf seals.
Good deal. So if you guys have any requests for samples, give us a holler or let Bailey know. All right, chain applications. So some of the dryer units out there, or even some of the frac sand type people, I guess you would say. Whoa. There we go. They're chain driven, so a lot of times you'll run into. Right, now we can see where the presentation's having fun. There's a little bit of a delay to hit the button. All right, so chain driven type application. So this is where a lot of your chains will shrink or kink due to the wear and corrosion inside the pin and bushing area. So that's the key part that you need to lubricate. So there's different approaches. You can either do it manually, which is not so desired. I can tell you that by the maintenance staff, because you know, I myself put myself in their shoes and doing it on a daily basis or weekly becomes redundant. But if you can do an automated system where it drips on or sprays on, you know, that might be something to consider as well. But focus on penetrating where the lubricant needs to work best for that chain, and that's in the pin and bushings. And what this does, it removes the contaminants and displaces any of the trapped water or anything like that, since they're typically running outside in the open environment. So if you got dust and stuff like that, this will constantly be cleaning them and taking those contaminants away, and it leaves behind a film of oil. Depending on what you're using, could be a little bit of a grease or solid. It all depends on what you're spraying onto the chain application. But just be aware of the pins and the pins and the bushings are the key component to be lubricating on that one. So.
Absolutely.
All right, let's see. And if you can, from application point, I'm going to move this so I can see the slack side. This is where the chain's going to be a little bit more relaxed. That's the area that you want to apply the lubricant. You don't want to apply it on the tight side. So when you get in a full strength and full load on that thing, it's difficult to have the lubricant wick into those areas. So if you can apply it on the slack side, that would be the most desirable area. Cool. All right. As I mentioned earlier on, Whitmore manufactures desiccant breathers. It's an air sentry line. What we do with these particular things, we typically do free surveys working with industrial kiln and dryer group, where we walk through the entire plant, and we'll do basically a product consolidation, but application. And we'll come back with a game plan of putting desiccant breathers on all the gearboxes, hydraulic reservoirs, the Guardian series. You can actually put that on your diesel fuel tanks. So on your mobile equipment, if you guys are experiencing, you know, high water, high dust, this might be a really good solution to help minimize those applications and headaches, if you will. Very easy to do and maintain. All right. Cool. And then there's the other reliability products that we offer with the Oil Safe line. So from bulk storage to the transfer containers to the lube points, where you're identifying what lubricant goes where on your assets, so you can help minimize cross-contamination or putting the wrong oil in there, or even the grease, because there's color-coded grease identifiers. Just to let you know, IKD has access to all of this. So if you guys are looking into doing something like that, give them a call, and we can take it from there and help them provide you guys a quote and also how to use this stuff. Bottom left-hand corner, there's a hub assembly for one of the Trunnion bearings. If you guys are looking for ease of sampling, visual identification, if you're looking to filter the oil, these are all things that we can do with one little setup. There's a filter cart, so you can hook up and you can filter your oil as the unit's running. Then we also came up with a Lustar units where they can either be wall mounted with a drum right underneath it. You can filter your oil there, because we all know that the new oil that you receive from your distributor or supplier is not exactly clean. You guys are the last point of contact that have the ability to do anything as far as filtration. So if you're looking for a certain ISO cleanliness of your oil, we provide those products at the plant level. You guys control it. You take all the guesswork out of, you know, relying on others to do the filtration for you. You've got that firsthand. And then also Industrial Kiln and Dryer Group has come up with their own lube cabinet. Buck, I'm gonna let you speak a little bit more on that one as far as your guys' solution, but I think it's pretty cool where it's a plug and play type of operation.
Yes, sir. Yeah, it's self-contained. It's a self-contained lubrication cabinet. It's, you know, PLC operated, and so it's programmed based on size, rotation, how many teeth on the gear. And so, I mean, it's set up to, and we can set it up with either kegs or drums, depending on the application. But it's one self-contained unit that would be, say, at the bottom of the pier, nearest the gear unit. One question that I had, Carl, was on the for the filtration. You had mentioned filtration. We can filter and help clean up the oil in the trunnions on the support rollers. What about gearboxes? Would it be recommended, or can we do that as well on the gearboxes? Can we filter and clean that oil going through the reducer?
Yeah, you can. It's very versatile. Depending on the size of the plant, if you've got a lot of smaller gearboxes or even the bigger ones, just be aware of what type of gear oil that you're working with on the filtration. So if you're using a polyalkylene glycol on your Trunnion, you don't want to take that same cart with the same hoses into the plant because you'll get contamination. You'll have that, you'll have two different carts, one for the plant and then one for the Trunnion. So just beware of what type of gear oil that you're going to be filtering. But yeah, you got completely flexibility of using the cart for those applications for filtration.
Excellent. Excellent.
Cool. All right.
That just adds another layer without having to completely empty the gearbox. And a production, from a production standpoint, we can get our oil cleaner and not cause any downtime or maintenance time for that.
Absolutely. So you can set it and let it run for 2 to 4 hours. You're good to go. So these are the products that the industrial kiln dryer are kind of running with. The open gear sorted clear, so that'll be your Lube XC Extreme. That'll be for your open gears and pinions for rotary processing equipment. The tire dry film. This will be more of your stop block support pads. The slipper pads is what we typically call that, but the applications for the inner tire bore. And then the heavy duty bearing oil. You can use the Paragon, which is your mineral paste. This will be for your water cooled. If you are some of those plants where you're using a synthetic like a PAO, that's an ISO 680. We do offer that one. We just want to kind of keep things simple on this one for this particular presentation. So your bearing oil, oops. Go back. There we go. It's working. So your bearing oil for synthetics, where you're using a PAG or polyalkylene glycol, we offer that one. And then for your bearings and your thrust rollers for the grease, we're offering the Matrix EP. So a very versatile product. This is where this product I can go into the plant and do a bunch of grease consolidation. So it makes simple and you've got less confusion when it comes to grease. All right, so that was just a repeat. The Molly blocks, that'll be the Whitmore solid stick lubricant, or SSL. This is for your tire support roller block. It's, competes with the graphite blocks that are out there in today's market. We do have a friction driven option as well. So just to give you an idea, as far as there's one that's for free floating, that'll be just a lubricant, and then the friction driven will be friction modified. And then the gearbox oil, this is the Paragon EP oil. This is where you're using ISO 220 to 320 throughout the plant and various applications. And then for the drivetrain lubricant, we've got the open chain lubricant. So we'll have to fix the spelling on that one. I just caught that. But yeah, this is where this is a mineral based. We do have synthetics and high temperature applications as well. So depending on that drivetrain, the chain application itself, we have that flexibility. So, but yeah, there's lots to offer, but we want to kind of keep it simple to the rotary equipment that we're speaking of today.
Again, this is just a basic lubrication. Hopefully, or not hopefully, but we've covered from front to back the major components, the things that we're looking for from a maintenance standpoint, the things that we want to lubricate well, that we want to address and maintain focus on. Feel free to please give us a call. That he's got the contact information up there through our website. Give us a call directly. You can talk with me, one of the key account representatives there in the office, or we can love to come by and visit with you there at your facility and walk the units down with you. Just kind of recap, this first session, basic lubrication today. Next Thursday, we're going to do it again. We're going to talk specific girth gear lubrication. And then on the 28th, tire ID, bearings, we're going to talk support rollers, thrust rollers, and all the oil safe accessories. So we're going to go much deeper into those topics over the course of the next 2 weeks. Before we go, we sure want to make sure, does anybody have any questions that we can answer for you before we let you go?
Or if you guys want to request samples or something like that through your reps, feel free to do so.
Absolutely. Yeah.
Good deal. Well, please provide any feedback. We're not perfect, but we always appreciate some feedback, good or bad. We always try and improve. So other than that, we wanted to keep to an hour's time frame, and we hit that goal. So if you guys are okay, I'll let Buck say goodbye then.
Thank you, guys. We really appreciate everybody joining us. We hope to see you again next Thursday at 1 o'clock. We're going to talk about girth gear lubrication. We'll also talk about chain-driven units as well, but that's going to be the focus. And we hope you guys enjoy the rest of your week. Have a good weekend. We'll talk to you next week.
Yeah,
Bye-bye.
Thanks. Bye, y'all.